All right, so this is the continuation of section 10.3. So we're going to be converting to polar form being that r comma theta. That means that the point we're given here, 0, 2, that we're going to convert is x and y. So we're going to use our formulas that are going to convert between polar and rectangular form. So we have these first two, that x squared plus y squared is r squared, and tangent theta is y over x. These are what we're going to use when we're given x and y, and we want to find r, and we want to find theta. So x squared plus y squared is r squared. So we're going to use x, y. We're going to find r. Now, here's the thing. When you get to this point right here, and we have that r squared is 4, remember when you take the square root, it's a plus or minus. Now, how do we know which one to use? Really, you could use either one, and I'm going to show you how that works. But for now, let's just use the positive one, just to make things a little easier for us. Also, if I graph 0, 2, we know it's right up here. So let's use that positive 2. And you can probably already tell what this angle is going to be, right? This is 2 units along that 90-degree angle, right? That's straight up right here. But let's go ahead through this tangent computation just to show you how that's going to work out. We get y over x, but check it out. We get y, which is 2, over x, which is 0. That's undefined. So how do you do that on the calculator? Your calculator won't do that for you. This is where you have to know that the tangent function is undefined at like 90, like 9 multiples of pi over 2. I don't have my first laminated formula sheet that has all the vertical asymptotes, or I'd show you what I'm talking about there. But we know that this is going to be 90 degrees because that tangent of 90 degrees is going to be undefined. So this one's actually pretty easy to do compared to some of the other points. If the point happens to be on one of the axes, we can just look at it and say, hey, that's 2 units away from the origin or the pole, and that's along that 90-degree route. So we get that polar form of r comma theta, 2 comma 90 degrees. So let's make it a little messier now. Let's go with -2 and then -2 root 3. We know that because this is a rectangular point, this is your x, this is your y. Then go through the same computations. X squared plus y squared is r squared. So plugging in for x and y, make sure when you square these that you're squaring that negative as well. So that -2 quantity squared is a +4. When I square -2 root 3, that's going to square the negative to make it positive. It's going to square the 2 and make it a 4. And it's going to square that root 3, which is going to give you 3. So it's 4 times 3, which is 12. So adding that together, we get 16, which is going to be r squared. And you take the square root, remember it's a plus or minus. So that's going to be plus or minus 4. Now, just to make things a little bit easier, let's just pick that positive one for now. When we get over here to the tangent's y over x. So when I plug in y over x, those negatives are going to cancel, become a positive. Those 2's will cancel, and I'll just get tangent theta equals root 3. We know that the angle associated with root 3 for the tangent function is 60 degrees. That's my reference angle. That 60 degrees, though, could be in either quadrants 1 or 3, because that's for the 2 quadrants where the tangent's positive. So how do we know which one? Well, let's go back to this point. This point goes to the left 2 units and then down 2 root 3 units. So it's in quadrant 3. So that means I need my angle to be in quadrant 3. So I need that 60-degree reference angle to be in quadrant 3. So 60-degree reference angle down in quadrant 3 is a 240-degree angle. So that puts this point the same as 4, 240 degrees. So there's the polar form of it. If you had chosen to use the negative r value, you could have. what you would have to do is use the quadrant 1 angle and the negative R value. So remember how when we plotted these points out, this one says find 240 degrees and go toward that angle, 4 units. So if we find 240 and we go along there, we end up down here in quadrant 3. This one says find 60 degrees and go backwards from it. So if this is 60 degrees right here, we need to go away from that 4 units. So these two angles are the same, or sorry, these 2 points are the same. I just wanted to show you that if you chose not to pick the positive R value, that you could have picked the negative one and the 60-degree angle. The biggest thing to remember is that you want to make a note of what quadrant this point is in and make sure that your final answer ends up in that same quadrant. Otherwise, if you just pick willy-nilly and you're like, yep, I'm going to go with 4 and I'm going to go with 60, you end up in quadrant 1, which is wrong. So you want to be very, very conscious of what quadrant everything needs to happen in. So this is another point that is x comma y, and it's going to be even messier than the last one. So we're going to start the same way we did with the others. X squared plus y squared is r squared. So plugging in for x squared and y squared, and then taking the plus or minus square root, I get plus or minus 2.25 approximately for r. And then the tangent, y over x, so I'm going to plug in y and x, divide those out, take the inverse tangent, and I got about negative 69.1 degrees when I did that. That's in quadrant 4. So I came back over here and said, ooh, what quadrant is this one in? This goes to the right and then down. So it's in quadrant 4. So perfect. That means if this angle's in quadrant 4 and that R is positive, I'm moving into quadrant 4. Now, some textbooks do not like it when you give negative angles for answers. I particularly do not care. But if that's the case, you could just find that coterminal version. You know, you can just find the positive version of this by just adding 360 to that. And we know that it would still be in quadrant 4. So it doesn't matter to me if you put a positive or a negative, angle for your answer. And I mean that, like, don't just make that plus, because that's a quadrant 1 angle. You can't do that. I mean that if you use those coterminal angles that differ by 360, it doesn't matter to me if you use the negative version or the positive coterminal version of that angle. Either one's fine with me. All right, how about negative 4, 3? So for this one, again, x squared plus y squared is r squared. So we have x, y. So we get r's plus or minus 5. Tangent, y over x. We're going to take the inverse tangent. We get negative 36.9. That's quadrant 4. But look, that point right here is not in quadrant 4. No, it is in quadrant 2 because you go to the left and then up. So that means that I need to find the quadrant 2 angle. This is the quadrant 4 angle. So it's down here, 36.9, reference angle down here. So what's a 36.9 reference angle up here in quadrant 2? Well, just take 180 minus this reference angle, and we get 143.1 as my quadrant 2 angle. So you have 2 options for your answer. If you go with the positive R, you need the quadrant 2 angle. If you go with the negative R, you could use the quadrant 4 angle that you found initially. So what happens is some students will say, if I get this and I say, hey, that's not in the right quadrant, they'll say, oh, that's cool, I'll just use the negative R, because that'll fix it, right? And it will. Whereas some students will just say, okay, I would rather just find that angle that is in the correct quadrant and use that positive r value. But both of these graph the exact same way. So remember, that's the thing about these polar points, is that you can have an infinite number of ways of representing the same point. So again, when you find that theta, if it's not in the right quadrant, see, that's 4, that's 2. If it's not in the right quadrant, you could still use this angle and just use the negative version of r to back away from it. Because if you're like, oh, it's in 4 and I need to be in 2, it's like, oh, well, let me just back this thing on up, you know? Beep, beep, beep. So you could do that, or you could find that quadrant 2 angle and use the positive r value. All right, so a polar equation is an equation that is in terms of r and theta. A rectangular equation is in terms of x and y. Okay? So I'm going to give you a rectangular equation in terms of x and y, and we're going to change it to a polar equation. So the rectangular equation is 3x minus y equals 6. Now we have these formulas from the formula sheet that help us convert between polar and rectangular. So you can see how I kind of color-coded these for you, that x is r cosine theta and y is r sine theta. So if I just substitute x with r cosine theta, and I substitute y with r sine theta, I get 3 r cosine theta minus r sine theta equals 6. Now, some of these will ask you to solve for r, you know, kind of like how sometimes with the rectangular stuff we like solving for y. So if that's the case and you have to solve for r, we're just going to factor an r out of these two terms and then divide both sides by all this mess in the parentheses. And we get that for r. And that's because I know this book and WebAssign really like for you to have it as r as a function of theta. All right, let's look at x squared equals 6y. So we're going to replace x with r cosine theta, and I'm going to replace y with r sine theta. So if I square this, I'm going to get r squared cosine squared theta equals 6r sine theta. This is going to simplify to be r equals 6 sine theta over cosine squared theta. Now you might be like, whoa, what just happened here? So that's why I put my little happy thought cloud up here. If I divide both sides, okay, if I divide both sides by this cosine squared, so I have r squared cosine squared theta equals 6r sine theta, and I divide both sides by r cosine theta. Look what's going to happen. Or sorry, r cosine squared theta. I don't think I said the squared by accident. The cosine squared is going to cancel. Look, this r is going to cancel one of these, and those r's are going to cancel. So that gives you the r by itself. We can do this only because we know that r is not going to be 0. So I can divide both sides by r. We wouldn't be able to do this normally if this was like a normal equation with x's and y's, because x could potentially be 0. But we know that r is not going to be 0 here, because it's the radius of a circle. So all I did was divide both sides. Now if you divide both sides by the cosine squared, you'd still have an r over here. So I went ahead and just kind of did two things at once. So that's what might be a little confusing. I divided by both this cosine squared and I divided by that r to isolate r. So I got r by itself in terms of nothing but theta. And if you wanted to be like, you know, super sassy about it, you could say, ooh, sine over cosine is tangent, and then 1 over cosine is secant. You know, write it that way, you certainly can, but you don't have to. Either one of those, just as good. All right, let's go in the other direction. Let's convert from a polar equation to a rectangular equation. These are not quite as pretty. You're like, holy crap, the other ones were pretty? Oh, Lord. R equals 10. Well, we know that x squared plus y squared is r squared. We have that formula. Well, that's hunky-dory, right? But I don't have an r squared. Well, boom, now I do. Check it out. I just squared both sides. So if I square both sides, I get r squared equals 10 squared. I'm going to replace that r squared with x squared plus y squared. So I get x squared plus y squared is 100. So that means the polar equation, r equals 10, is the same as this rectangular equation. Both of these are circles with a center at 0, 0, and a radius of 10. So r equals 10, radius of 10. All right, r equals 6 secant theta. So I'm going to rewrite that secant as its reciprocal function. So we know that secant is the same as 1 over cosine. So I'm going to write that as 6 over cosine. Now the reason I'm doing that is because, watch, I can then cross multiply and get r cosine theta equals 6. I did that because from my formula sheet, I know that r cosine theta is x. So that just replaces all that with just x. I get, boom, x equals 6. So these really require some, some trickeration going on here. All right, now we have r equals 8 cosine theta plus 2 sine theta. Man, it would certainly be super duper special if that were an r cosine theta, right? Because if that were an r cosine theta, booyah, x. If that were an r sine theta, booyah, that'd be a y. Well, I mean, there's not an r there. Let's just bring one in. Let's just multiply all of these by r. Let's multiply both sides of that equation by r. That's actually kind of cool if I do that, because now that's an r squared, which we know is the same as x squared plus y squared. So now I can replace r squared with x squared plus y squared. 8's along for the ride. Now we have that magical r cosine theta, which is x. 2 is along for the ride, and we have that r sine theta, which is just y. All right, so that concludes section 10.3.